Sorry for the slight delays. So I'm Michael BarSinai from Orlando, and we're going to talk about model-based testing. It's a tradition, I think, in the world of testing that every few years comes along someone that says, model-based testing is an amazing tool and we should all use it. And then another like 5 years go by and someone else come with this idea. But it is a good idea. I think this time it might be a bit different.
Your Persian's really good.
I know. Yeah. So I definitely. So think about AI and like over assistive technologies. It's going to be in English. I know my English is like not would be improved, but it's pretty good. I could use like a more friendly feedback. This is Persian, right? You're speaking Persian. Sounds like Persian. Okay, so okay. So luckily we had a lot of delays, so I don't need to spend a lot of time here. But basically, I've been programming for a while, since '98. At some point, I turned into, and I did a lot of like quality stuff where quality is important, but airline departure, control systems. I did not do the luggage part. So if your luggage, but I was more in the seat map. If you're like mis-seated, that might have been me. I did some data science tools at Harvard at some point, and I did some built to academia where I stumbled on this idea of model-based testing or model-based software engineering. Really, and I thought it was really good, really cool thing, and I was wondering like why nobody's using it. And then I studied it some more, and I was like, oh, this is why it's not being used. But it is a cool thing, and I started studying it a bit more. You guys in the lab, and at some point we figured that we'll put our money where our mouth is and actually try to take this to the industry again, but this time differently. Questionable decision, but sleeping is overrated, and we're having fun. Also, like because I make bread sometimes and try to ferment things. Sometimes it works, but it's a different content. Okay, so well, I don't need no for help. It goes to Zoom. I don't have Zoom in the phone. It has like a small thing like that. Don't aren't you hearing it? Okay, so model-based testing and why do people think it might be a good idea? So basically, it allows us. First of all, it's a kind of a power tool. Okay, but and it can go. It's a scale. It can go from just being a testing power tool to a complete, not complete, but to upgraded software development lifecycle, as you'll see. And it offers a lot of things like focusing on the requirement comprehension rather than scenario maintenance or test scenarios. And it can increase agility and coverage at the same time. There's a lot of good ideas and things that makes it something that people might want to try to deploy. But of course, your mileage may vary. Terms and conditions. It's not like you just sprinkle it on top and stuff starts working. But at any event, it's very different. There's a very different take on what we normally have as quality. And so even if you go from the talk saying, this is okay, we're going to wait 5 years for the next guy to come and say, look, I should really use that thing. I hope to at least give you a new perspective of testing quality and how to approach it. It's basically approaching for the same goal, but from a different angle. So how testing is done today, we all know, right? We have this document that we need to make sure or have at least some notion of how a software or feature that we're about to release behaves properly or behaves as it should. So this begs the question of how should it behave, right? So for this we have a text document normally, or a few text documents, and some requirements, use case or something. normally followed by a lot of messages and Slack messages and corridor conversations saying, well, actually I wrote that, but I meant that thing. But starting from that, we just, we deploy our methodologies and think about it and ask clarifying questions and end up with a set of tests. Test scenarios that needs to be maintained and then executed. And the process is mostly manual. GenAI could help here, but what GenAI do is what it does with normal programming, right? So if you want to, you can theoretically throw all this to some model and get a lot of test cases, but in order to validate that the test cases correctly test the behavior, you need to read and understand these and then read and understand the test cases. So you become more of an editor than a writer, but you still need, AI can't understand the thing for you. You at least need to check it. And obviously when there's a change, like if there's a change in requirement or some misunderstanding or somebody asks something and the clarification meant that you need to do something different somewhere, then the downstream needs to be updated, right? So this is one way of tackling this currently is test parameters and stuff like that, right? So the most complex end-to-end scenarios, we have a few of those because they break very often. Anything here might break them. And you might have like a 300 strong regression test suite on Monday, but on Wednesday you have a 300 strong maintenance problem in your hands, right? So we normally, for the actual automation, do regression on stuff that's stable, because maintenance is an issue. Okay, model-based testing, it takes a different approach. We start with the same thing. Okay, we're not going to fix how product works yet. I mean, not on this slide, on the next slide. But instead of going straight to the test scenarios, we go with the model. Now, the idea is model is it's basically something a computer can use in order to generate tests. Okay, we have a lot of types of models, and we look into a few of those. But the idea is once we have the model, we can generate the tests or a test suite actually in a way that's automatic. So I'm not saying like completely deterministic. Okay, you can use some AI here, you can use some kind of random things, but at least it's very reliable. Okay, the moving from the model to the actual test is more like compilation. Okay, like you compile Java code into something that can actually run. So that would be the same thing. So now this part is automatic, and we can generate tests. And because it's an easy task now, we can actually generate a lot of test suites out of it. Okay, we don't have to generate just one. If we need to focus on some specific areas, we just change a bit of the generation here, and it's run. And we can also target multiple things, right? So we can target automation, or we can generate script that will do the automation, or we can automatically generate manual tests. That also works, which is kind of like maybe counterintuitive, but this is something we can do. Okay, so we basically get the idea that we have a test generation machine. It's a power tool. Okay. So you bring this to IT office. You like plug in the specification. You just generate a lot of test case scenarios. You don't have to run them. In fact, you probably don't want to run them because it's a lot of them. What we can do is just reason about them, store them somewhere, and when you want to test something, you just select the correct tests, and you run them. You run what you test, what you need to test. Okay, so it's a two-phase thing. First of all, is the generation of test cases, and then test suite composition. Okay, so this is the promise if it works. Now, if there's a change, it basically ends in the model. Okay, so maybe we misunderstood someone in the product, maybe the product didn't understand something. Not that it ever happens. Being recorded, right? But if anything changes here, we just change the model, and then we just throw all the test scenarios and regenerate. Okay, so all the maintenance, the test scenario maintenance, I'm not saying it's zero, but it's the change effort is proportional to the change in the system, not to how many tests we have. Okay, so it's very easy to have a lot of tests out there, and if anything, it's a problem, we just throw the test away and generate stuff. Another thing we can do, and we'll see this in a few slides, because this is an actionable system. So if you have, it's something a computer can understand and analyze, right? So if you have a good model, depends on the model, but if you have a good model, you can actually find all kind of problems in the requirements. So finding bugs of the products before the system is implemented. Weird, but it's something that we'll see an example of this. So this is the promise of model-based testing, right? And it's been around for a while. And so what's not to like, right? But given that it's been around for a while, the question is more towards like, where's the catch, right? Why hasn't this caught off? No. Okay, so I started saying it's been around for a while. I tried to find the earliest thing that's kind of like mentioned. The first product was developed in 1997. Something called Testmaster. We'll see a screenshot, but the idea was there before. So I tried to understand where it came from, like what was the initial thought. And I stumbled on a paper about software testing. It's pretty early. Published in 19. Anybody want to take a guess?
Is it from Turing? Is it from Turing?
Yeah.
So
1949. So 1949, the man himself, Alan Turing, they didn't test software, they checked routines back then. But this is the paper is available online, by the way, the Turing Digital Archive. It's like a 2-page paper. And it's pretty forward-looking for something for 1949. For example, it talks about the stability, right? So instead of having just all the big algorithms, says the programmer should make a number of definite assertions which can be checked individually, right? So this is basically the stability, right? If you break problem to, it's very forward-looking. We'll get to the part where it talks about playwright versus language. But the other thing it talks about is the idea that the programmer should make the assertions about various states that the machine can reach. Okay, this is in order to assist the checker. So it's also talking about this the process of dev and QA working together. But this is something. This is more of a test thinking than a programmer, right? Because programmers normally try to just get stuff done. Whereas test engineers normally try to say, okay, I want to look at all the possible runs of the system, and then almost like in SQL query, right? Saying, select star from possible runs where bug equals true, right? And then get all the possible runs when we have a bug. And then obviously not release the system until this query returns empty list, right? So he's talking about all possible runs. And this really started, was one of the earliest instances of talking about formal methods, right? Which is an idea of field in computer science where we try to look at all possible executions and prove that there are no bugs. Now, this actually can be done. In the essence of time, I'm not going to go into that, but for high assurance military stuff, like this helicopter over there, people have developed software that's proven to be bug-free in certain aspects. Okay, but it's very, very expensive and can't really get it's just too expensive to become mainstream. Also Amazon, by the way, Amazon permission, AWS permission gives also works the same idea of formal methods. Okay, so this is the first time that people actually try to do to look at all the states, but not all the states of the software, which is, as I said, it's hard. If we can look at all the states of a test, that would actually be easier and more natural for testing. And this is the first system that did this semi-commercially. It's Michael Apfelbaum, I think, 1997. And the idea is that we have a PBX, like one of those phones. phone switchboard, digital phone switchboard. And this is a state machine, which is normally what model-based testing is associated with. And everything starts here, right? And we go to in-caller main loop, and then we can go like in-caller market agent and go back. And then maybe we'll do install, throw it away and go back. And so, okay, so each line of this state machine is a valid test. Now, how many tests do we have here, by the way?
Zero.
Zero. Why zero?
Well, I mean, you haven't defined a specific test. There's a state model, there's a model, but no tests have been.
Well, assuming there's a code that does automation on the end. So you go here and it's like, okay, you in-caller bad entry is something you do. Okay, there's like code behind this that actually runs stuff.
So I should assume one test per node?
Okay, so we have an infinite number of tests. Right, because the test can go like, we can go here and then here, like here, and go back and then maybe go there and back, and it's all valid tests. Okay, and for example, in the encoder Sandy, for example, you can't go straight back here, you have to go through the bad entry and then maybe go back. So this basically defines the infinite number of tests, and they're all valid, and it's something that works. The problem with this kind of thing, and actually, and you can get them today. You can't get that, but there are open source systems that do all these kind of state machines. The audio is terrible. Okay. Is it better now?
You can't give the.
That would be a big neck mic, but I can do that. Oh, so it's fine for me. Thanks, Jeff. Okay. So the main problem with these kind of systems is that it's really hard to build a model, or it used to be hard to build a model. That's so the biggest problem for model-based testing used to be the model itself. It's its own worst enemy. But this change, and the other thing is, follows from this is the fact that there's very little ecosystem and very little training for it, and then there wasn't enough incentive for this, so development was quite slow, right? So it wasn't that much of a problem that we couldn't do automation fast and we couldn't do good coverage earlier. But this changes with the two factors that we have. First of all, it's Gen AI, obviously, makes model creation easier and also makes developer run faster. And also there's new model types, so we don't have to do just state machines or decision tables or stuff like that. We can do better stuff now. Gen AI, you'll probably see a lot of this, right? So Gen AI generating all kinds of outages, just running a lot faster, but not more accurate. But I think the best way to depict how Gen AI works with current development systems is this kind of card. Right? It's kind of like we move faster. Okay, we definitely have a bigger engine now, but we didn't reinforce the steering or the brakes. So it looks really good when it's parked, but when you try to deploy it, you at least need to get a good insurance. And actually, people are sharing insurance for AI issues now. So this metaphor actually works. Okay, so I'm going to look at one example of how a system could be tested using model-based testing. How much time do I have? Well, I mean, I don't.
I'm not even sure what the schedule is now.
Okay, just throw something. Okay, so we're going to look at a simple, almost silly case. Look it fast. That is, we have a kid going. And they need to get ready for school. Okay, you can imagine at which point in the day I came up with this example. And this is basically the scenario, right? Wake up, wear clothes, brush teeth, tidy up, and go out. So if we look at one possible implementation, this is our system, but we have more of this. So we basically just defined that we wake up. They didn't tell us what the order was. So I'm not telling the system what the order is. Okay, this is one of the differences between testing the thing and implementing the thing. Implementing, if I didn't tell me what order it was, I just pick an order. right? Here it's not set up, so I can just say, okay, do all the orders. Get dress up and tidy up and go out. This can be executed. We can look at this in the open season part. But we can also draw this. Okay, so this would be the generated state machine, where each scenario really starts here, and we go through some part and then we go on. So this doesn't have infinite amount of tests. It has just a lot amount of tests for a very small amount of code. And okay, so this is how it's implemented. Now, maybe one day, suppose there's a change, right? And kids come back home from the kindergarten and says, well, we have this, the teacher gave this to me, and you read this and go, okay, you call your lawyer friend, and the lawyer says, well, just don't send this kid with the socks over the shoes. Okay, that's it's weird and people don't play with them. Okay, so we can check that, right? But again, this is model-based testing. What we want to do is utilize the model, right? So remember when I said like select star from runs where bags from. This is how it would go. Okay, we're basically saying, okay, I'm not going to look at each individual scenario. I'm not going to look at the state machine that are working this. I'm just going to add this, saying if shoes happens and then socks happens, then just breaks. Something's wrong. Once you add this, the system actually, not only it tells you where this happens, okay? So this is the classic formal methods, a lot of examples out there. You can also see the trace getting up to it, leading up to the bug being generated. Now, whose bug is this? The fact that we were allowed to do this in each order.
Clearly the shoes team.
Hmm?
Clearly the shoes team.
Definitely they should. Yeah, they're just trying to push themselves. Okay, so this, first of all, you can see that we found this bug. There wasn't any automation involved. Right? So this is a classic product bug, really. This is really the QA telling the product that they're violating what legal said. Okay, there's no developer involved here. There wasn't even implementation. Okay, so this.
Would you say this is complete?
In what sense?
That there is no event that can happen in between, say it falls asleep?
Yeah.
After
This is complete. Yeah, you can see all. You can actually see all the possible ways.
Okay, how about the kid falls asleep after putting on one sock? Falls asleep again.
Oh, okay, so great question. So the question was if the kid falls asleep in one sock in the middle. So this is not modeled here, so it wouldn't be covered. So that's one of the limitations. You need to have at least you need to have the notion. It would be easy to add if you have this. We can play with it better. Okay, now just to add, to look a bit on test suite composition. I keep like butting forward because I don't have the presenter screen. I always see this animation. Okay. Okay, so now just I'm going to add breakfast to it just so that we have more easier examples for composing stuff. So I added this select thing here about type of breakfast, and you see it's, for example, maybe basically it's complex splits. We now have two test cases, and this is how it looks like. So this is the model we had before. We added this code, and now we also modeled breakfast in, or the ability to skip breakfast. And there's a lot of tests here. So if I'm asking the system to, for example, cover a goal that includes eating banana, eating salad, eating cereal, eating a healthy breakfast, which is not mutually exclusive, and also skipping breakfast, which is like this thing here, and do it with 5 tests. The system can compose this because it can reason about all possible tests. Basically, okay, so if I'm trying to do the same, but okay, I think there's a problem when we wear the shirt last. Okay, I know there's always like an issue there with different prints, and the kids not sure about what print, and he's awake enough to actually like hold his own ground. So I can basically tell the system, okay, I want 5 tests that cover wearing shirt last, and you see that all the tests here go through the shirt, the last word. Okay, so basically just scoring the system saying try to do the most thing before you version. Okay, so far what we modeled was behavior, application behavior. Using similar tools, you can model parameters for an algorithm, right? So this would be like more useful for an AI. If you want to check an AI bot and you have this whole parameter space of how to check things, this would be a good way of doing it. This is insurance, which is obviously is like very non-slide friendly with all the options they have there. The other thing about this, okay, so this is, and then once you, yeah, this is the insurance one. So another cool thing is because the system generates the tests for you, the metadata is built in, right? Because you always have to tag your scenarios properly, right? But because they're computer generated, you can just tell the system to generate it for you. So basically just defer the non-interesting stuff to the computer. And so you can get, I mean, this is a generation of manual test out of the system. It could really use what? 10 minutes. Oh, okay. Running really fast. Okay, we can slow down. Okay, another thing I'd like to say about Gen AI here, right, is that unlike when you do Gen AI for code, the problem is it looks good, right? This is what it's trained to do. It's trained to do something that looks, this is what it knows, right? What's the most likely token to appear after the before thing? And one of the main problems with bugs getting into production from Gen AI is the fact that the code is not immediately, the bugs are not immediately clear. However, if you use Gen AI to generate models, you have two things working for you. First of all, models are by definition simpler than the system they model, right? Otherwise, there's no point making the model. It's all about simplification, right? If your model is more complex and harder to maintain than the system, not a good implementation not a good application of the methodology. The other thing is that as you see, we can visualize what is generated, so we can. It's a good communication tool. You can show it to non-technical people. You can show it to the client. You can, for example, this kind of thing when you're about to, approve a test plan. This is a pretty useful aid, right? People can say, well, you're missing this thing. I think it happened in productions. Add that. So it's much easier to understand what the Gen AI did when it creates modeling code. And also you can use the verification part, like what we've done, what we've seen, this thing, we can use it in order to validate, make sure that the model does not contain errors. So if someone introduced by accident, suppose you're doing a bank thing and someone did a rapid funds transfer feature, and they forgot the whole know your client thing, which you have to do, right, by legally required to do. You can actually verify that before each transaction, there's a KYC verification, right? Know your client verification, and you can, if the Gen AI or the product using Gen AI introduce something that's violating that, you can find this automatically. Okay, so how can this affect the SDFC? So normally what we have is a customer coming up with a mess of semi-baked ideas or somewhat baked ideas, but not fully productized. This is why we have the product or they go together, put it in the backlog. And now they talk to developer and QA. Developer starts working, QA pairing. And then we have the normal QA to dev loop and end up with a release, right? So this is how it works today, and we try to shift left as much as possible and do all kind of these mixed teams and everything. But basically, these are the stages. Now, with model-based testing, this could work different. Now, this is like possible future. Okay, I'm not saying it's going to happen. I can say that I did see something like this happen in the wild, where QA basically altering or making product alter the requirements based on one of those diagrams. So that's a proud moment for everyone in the room, except for the product. That's a different thing. But again, taking this all the way to the end, we started with the product working with the QA doing a high-level model, making sure that nobody gets hurt and basically requirement clarification and making everything is proper. And then they get into the actual development stage where we clarify the requirements that we know are at least legally okay. Then we have the normal loop, except that now, so we didn't touch automation, but it's basically much easier to automate the model once when you have it. Okay, because you're basically just detailing this box, or when we say this, we actually run this Selenium command or running this API call. So it's actually easier. And then when QA is happy, then we can release. Okay, so basically this gives us, first of all, it puts QA, shifts QA much lefter, yes, I know. But also this is a very cheap feedback loop because it doesn't involve any code deployment. It's very easy to make changes to the model. Again, unless of course the model is, if the model is done properly, this is very early and cheap, so we're much more agile than it could be. But again, this is like a utopia kind of thing. We can move towards it, obviously. Okay, now I did mention that it's not a clear winner. So when to not use model-based testing? First of all, some things just can't be more, right? I think this sticker is that you can't automate curiosity, which I thought was good. So let's think of that sticker. Exploratory testing, for example, that's one thing. We just go in and try to break stuff or put the system in weird situation. That's almost the opposite of model-based testing, right? Model-based testing, the idea is that we know ahead of time what's going to happen, and then we try to execute it and see if it does happen properly. So they're almost they're like complementary systems. There's obviously a learning curve to it. So if you're stressed for time and people and stuff, and that's probably not might not be the right time to introduce this. Organizational resistance to change, obviously. I don't think people can. I mean, it's basically a power tool. Okay, so it's a powerful tool for testers, but it's something that some people are afraid of. I've seen that happening, and also the first few times you're probably not going to get it correct on the first try. So if you want to adopt it or look into it, just give it a bit time. So in summary, the basic idea is that we explain to the computer how the application should behave in a way that's computer actionable, and we generate scenarios and test suites and also insights about the intended behavior. Becoming much more agile, but not at the cost of test coverage. I think that's one. I mean, one of the main choices we have to do is being agile or having good automated test coverage. This actually really solves this problem. And also easier to have keep the stakeholder in sync with all the visualization and stuff. Works well in Gen AI, both in the generation of the models and with the testing of the models. So we're moving faster or as fast as the rest of the development team. But again, some terms and conditions apply. So, okay, first of all, this is our release. This is how that's the model for our version release, which is just, I mean, we have a lot of tests here. Anyway, that just shows you that it's happening. More resources. First of all, first formal methods been around, as I mentioned, is 1949. But so these are basically the keywords you want to look model-based. I think there's a lot of stuff out there. Not all of it is updated. Browser stack have like a nice write-up I also humbly recommend our like YouTube channel where I try to explain things, sometimes successfully. There are tools such as GraphWalker, it's open source, they're mostly a solution thingy. But it's a good way to get your feedback, or obviously, if you want to use our tools, also way. Yeah, so open season. No? Okay, open season. Have your cards ready.
Yes, I remember the green, yellow, red, please, and, anyone else questions?
Yeah, yes.
So I find whenever a programmer presents this, this technique, they start with formal methods. They think about things in a very deterministic way.
Right.
What would somebody without that background or that training? I mean, how do you think they would approach model-based testing, or how would they use it as like a capturing of requirements?
So, just like you said, it's capturing of requirements. One of the problems, I mean, I tried. So my experience with this is that you don't have to have formal method training. That was one of the initial barriers for adoption, that you need to have like a graduate degree in math or something. And people that used to deploy this were actually IBM would place, like, I think IBM would place like a team of PhDs in the organization, and the help and stuff. It's not really true anymore. With the new system, especially with Gen AI helping you, and with the non-technical, anyway, it's easier now. Okay, so I've seen people that had like 2 months of test automation Python use our system. Okay. So it shouldn't be a barrier anymore. I do find that formal method thinking, like Turing said, just think about all possible things. Actually, maybe engineers need to learn it, but for a QA, that's the basic thinking, right? So let's look at all possible. What happens if I move the window here? What happens if I do that? Here's a combination. So I don't think you need the formal training for formal method. You can just like come with your own thinking, and that it's a bit more natural, probably. I guess.
You worked in some environments where risk tolerance seemed fairly low, particularly in the airline industry.
Yeah. Oh, that was long ago.
Yeah, so, yeah. Essentially in the model-based testing, you're trusting the model as part of your verification, validation of the end system.
Mhm.
What do you need to do to verify or validate, qualify that model in order to be able to have a substantial level of trust?
Oh, good question. So basically, we're able to determine whether the system behaves as the model tells it, but we need to determine the model, right?
Mhm.
2 things. First of all, models, as I mentioned, they need to be simple. Way simpler than the system. And normally easier, very easy to do, because it's a black box. And whatever the box is, right, we generated unit test through model-based testing, but the unit itself was pretty complex, the class. So we have 2 things going. One is the formal verification. So you say what the model can't do, and you just add it, and you make sure that no errors are there. So you know that at least you're within these guidelines. This is something you can automatically verify in a sound way. And the other thing is visualizations, or generating a few scripts and just going on through them manually. It help you build trust in what you're about to generate. And the visualization is something that you can take to non-technical people, the subject matter experts. It is how it should be. I actually had this case in an insurance company. We had we were working on some like apartment insurance, and it's like an old AS400, 30 years of logic. Nobody knows. There wasn't a central place for it. So what we did was basically generate a model, no automation at this point, And then the person I worked with just went to different people in the organization with the PDF, like, is this right? And they said, well, no, you actually have an error here and an error there. And a few iterations later, we actually had a documentation of what happened in the last 30 years, I think. There was nobody else, nobody survived to contradict what we were doing. And we're also able to deploy this logic in a testable way. And I got to automate the mainframe, which was cool.
So you're basically breaking requirements in the use cases. From the use cases, you're building your model. Loosely.
Yes, if you're doing a behavioral model, then you do use cases. You can also do interweaving use cases. So you have, that's one of the great, I know we haven't shown it yet. So, but for example, if you have two users running together and you start getting all kind of race conditions, right? So we found one bug in learning LMS, like a learning book, one of those like a class systems, course organization systems, where you had the teacher was able to change a test while someone was taking it. And the way we did it, we just had two use cases. One is a teacher logging in, taking an existing test, changing it, and we ran it along with a student logging in, taking a test, and submitting it. And the system creates all possible interweaves. Normally it ends up being a huge, obviously, test space, but if you have time, you get all the cases. And you get the reproduction, the way to reproduce it as well. Infinite?
That's my name.
Yeah, well, that's.
My parents, weird.
Yeah, the gentleman in the blue first.
Yeah.
So, how is model-based testing different from combinatorial testing? How list of inputs, kind of try to.
It's not. It's combinatorial testing is one example of model-based testing. So the model, if you were to model the input space of a system, then it would kind of be combinatorial testing. And you can also do like pairwise is another way of composing a test suite. Right? It's just by saying, okay, I want this type of event, I want all pairs of this type of events, or a three-way. It's a good way of generating like a risk-based use case.
Thank you.
And we have a couple more minutes.
Yeah, so just a question to the requirements, which is a finite list of expected behaviors, let's say, something that you can check against and verify. And then there's an infinite list of behaviors that should not or must not happen. So like, and one thing that's always true, that no application shall create a black hole. So that's so it's an infinitely large list. And given that the model is derived from the finite list of verifiable items, is there enough awareness that just using the model to generate test cases is not enough to not run in danger that the application does something that is not desired? Because often those things you only discover when they happen. So by observation of a behavior of the software, you discover that this is something that's not desired, and so that they can be covered in the model.
So if it's not
In the
part
model.
of the model, so if it's not part of the model won't do. This is why I said it's not. That's right. This is why I said it's not. It can't replace exploratory test. Because it's the type like generate a black hole into the prompt, and if it is generated, then yeah.
I've always
Bug found.
I always do this test.
Yeah.
That's super cool.
Also, it was you.
We've got time for maybe one final question, so if anyone has.
So how did you solve, we've done the model-based testing a while back, years back, but how did you solve parallel testing? And how did you solve versioning the diagrams that you created? So you can solve the.
Right, okay, so finite testing?
How do you test in parallel? Because for us, we do regression, when we run a model-based testing tool, it runs so slow, especially if you connect it to a UI-based automation. API is no problem. But connected to a Selenium, for example, WebDrive is so slow. Because it does the model sequentially, right? Not all it has.
So, the first one is, so the model-based testing kind of assumes that it owns the system, nothing else happens to it. Like, we're the only thing that does stuff to the system at the point. Otherwise, it's not, the model is not separate, so you get flaky tests by definition. What we did, I mean, we operate Selenium, I don't know, it's pretty fast. I don't know the implementation there. We can also generate test code, like generate Python, which can be run on like different systems. But that's what it's kind of like a technical thing. The other thing about models being large, so one thing we do is verification, which not all traditionally model-based testing tools don't do that. Or at least I haven't heard of any of them. Doing formal verification of the model itself, so containing errors in the model. And the other thing is just visualization and generation of, we generate like manual test books out of it. But I'm doing quotes because it's without the actual, we use our tools for generating test books, manual test books to see how, which scripts are generated. And then build trust in the model. So you look at like okay, generate, I don't know, 10 tests. And then you can go over them and see that it makes sense. But yes, I mean, as the model grows, it becomes a bit harder to be sure it's complete.
We are up in time.